Hey, Hux. So, the last thing that we need to learn in this unit is how molecules are shaped. Okay. And so, how can these we call it the VSEPR model of and Lewis structures be used to predict a compound's molecular geometry, where geometry in this case means its shape? I will use the valence shell electron pair repulsion, that's VSEPR model to predict the geometries of molecules. Okay, so molecular shape. The shape of a molecule may determine its properties and uses. So if we look at aspirin, aspirin has a specific shape so that it can block certain enzymes from excreting or releasing other types of substances into our body. So, like, when we get pain, those enzymes are the ones that they're producing a they're producing a substance that the nerve ends will react with, right? That they'll be able to send that message to the brain will go ouch, right? But if we use aspirin, most specifically probably ibuprofen, it will block that enzyme and make it so that it can't release that pain inhibitor. Okay, so properties such as smell, taste, and proper targeting of drugs are all possible because of the shape of the molecule. Okay, so molecular shapes. Your Lewis structure doesn't give you a three-dimensional view of how the atoms are bonded together, but it can give you an idea. The Sepper theory, which is called valence shell electron pair repulsion theory, okay? And its main premise is that molecules will adopt a shape that is lowest in energy by minimizing the valence shell electron pair repulsion between adjacent atoms. What that means is if there are electrons paired up, say in this molecule here, you've got a bond here and a bond here, they will repel each other to a certain distance, right? And in this particular shape, it always repels each other to be 109.5 degrees apart. Okay, so in other words, atoms in a molecule try to spread out from one another as much as possible to reduce the like charge repulsion. That means like electron to electron, right? Negative to negative, between their outer electrons. Okay. There are 6 basic shapes. You do not need to memorize them. You should have gotten in your packet a what we call the shape sheet. It has these pictures on it going the opposite direction, as well as all of the information that you see here. So the first one is linear. It has 180 degrees, right? So that means that all the angles are 180 degrees and there are no lone pairs. Now, a lone pair would be on that central atom, whatever the one or two are that are in the center, are there electrons that are all by themselves. They're not being shared. They're not bonded, okay? There's bent, which has an angle of 115 degrees and has one lone pair. There's bent with 2 lone pairs, and that's you can see where there's 2 pairs here, and the angle is only 105 degrees. There's triangular pyramidal, which is an angle of 107 degrees, so each of these is 107 degrees, and there's 1 lone pair. And then there's trigonal planar, So these are all kind of in one plane. They're not 3D. And that angle is 120 degrees with 0 lone pairs. And then there's tetrahedral, where the angle is 109.5 degrees and there are no lone pairs. Okay? So those are the 6 shapes. Let's use an example to see how we figure out how those shapes come about. How you determine what those shapes should be. Okay, so here's our first example. We have oxygen single bonded to a nitrogen, single bonded to a chlorine. Okay? And so if we look at our shape sheet, this is the sheet that was in your packet. The first thing that I do is I look at how many atoms are there, right? How many individual atoms are there? So in this case, we have 1, 2, 3. So when I look at my sheet, I'm looking for the number, right? So 1, 2, 3. That means that this one has 3 atoms, okay? 1, 2, 3. This one has 3. 1, 2, 3. This one has 3. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4, 5. Okay? So, as the number of atoms, we can only look at the top 3 because our molecule only has 3 atoms in it. Okay? So, then when we look at our our molecule, we notice that there is a lone pair on that central atom. And what that lone pair means is that there are 2 electrons that are not bonded to anything. Okay? There are 2 electrons right here that are not bonded to anything, which means they're not being shared. They're just in the nitrogen. So if I look again at my shape sheet, I can see that I have the top one where they're all pretty much just the same. There's no extra electrons anywhere. Then I look at the second one. This one's got 1 lone pair. And I look at the next one. This one's got 2 lone pairs. So for my molecule, I want 3 atoms with 1 lone pair. So that means that it is bent and it is 117 degrees. So it's bent at 117 degrees. Okay, you would write both of those down. Okay, here's our second example. And if we look, we have 1, 2, 3, 4. So that means that it can only be one of these 2. Okay, if we look, this one has 1 lone pair. And if we look here, this one has 1 lone pair. So this one is triangular pyramidal. Okay, here's the last one. You have 1, 2, 3, 4, 5 atoms, and on our shape sheet, the only one that has 5 is tetrahedral. So the answer would be tetrahedral, and it's 109.5 degrees. So you should be able now to be able to go back and identify the shape and the angle for each of the molecules that you have drawn so far.